This is going to be another rule for finding derivatives, and the rule is going to apply to exponential functions. And so when we talk about exponential functions, we're talking about functions where you have like a number to a power. The x is the variable, it's in the power this time instead of being the base like it was in the power rule. So before I show you the rule, I want to talk a little bit about the way the graph looks. So exponential functions look kind of like this, or like this. So if I think about the derivative of these, I'm thinking about, like, how would I draw it? So the slope is positive all the time on this one, and it's 0 at the beginning, and then it gets bigger. So if I draw the derivative here, it's going to look very, very similar. It might be a little bit more steep, but the shape is going to be the same. Same thing happens on the second one. It's negative. Well, it's a little different on the second one, and I'll show you what that has to do with. But it's negative, and that part stays that part changes, but it still is going towards 0 at the end, and it's really big at the beginning. So I flip it over the x-axis, and I get something like that. Now today, we're only dealing with this kind, the y equals a to the x. We will deal with what happens with that negative, but the function still looks very, very similar. So the negative is only going to be affected just with a negative. So here's your rule. If you have y equals a to the x, where a is a number, then the derivative, y prime f prime of x, is natural log of a times a to the x. So that natural log of a is a number, and so what it's saying is that the shape is the same. They both have a to the x, but with this ln of a, it makes it a little bit more steep or a little bit less steep, depending on the value of a. Now, there's actually two rules, and the second one is y equals e to the x. It's basically just an extension of this rule. E to the x is an exponential function because e is a number, and if I find the derivative of e to the x, if I do it like the rule up there says, then I would do natural log of e times e to the x. But here's where it's important. If I figure out what natural log of e is, what that means, and I know it's been a while for some of you, but let's say we were trying to figure out, I'm going to call it a instead of y, what natural log of e was. Well, what you do is you put an understood base of e, since it's natural log. You raise it to that power, and it equals that. So natural log of e equals a means e to the a equals e. We're trying to find a. A is just 1. And so what that tells me is that natural log of e is 1. So down here, on this natural log of e times e to the x, natural log of e is 1, and then we leave our e to the x. So what we find out is that the derivative of e to the x is itself. And it just has to do with the shape and the slope. So this is the real rule, where you have y equals a to the x and y prime equals natural log of a times a to the x. But this is also a rule, but it comes from that first rule. And I just call it the exponential rule. Just be really careful not to treat it like the power rule. Okay, so here's some examples. Alright, on the first one, it's the exponential rule. Since the x is in the power, and so to find the derivative, I'm just going to use that first rule that we said, natural log of a times a to the x. So a is like the 5, so you'd have natural log of 5 times 5 to the x. Just be careful, notice that the natural log of 5 is not raised to the x power. Alright, number 2. So this one is a number times an exponential. And if you have just a number times something, or times a function, then what we learned today was that you could find the derivative of the function and then just multiply it by the number. Same thing's going to happen. We're going to leave our 3, and then the derivative of 2 to the x would be natural log of 2 times 2 to the x. You cannot multiply the 3 and the 2 because they don't both have the same power. Number 3. Again, very, very similar. I like to rewrite this one as 1/3 times 4 to the x. I just think it's easier to see what you would do. And you don't have to do that, but I think it's easier. Because we're not just finding the derivative of the top and then putting the bottom down. I'm finding the derivative of 4 to the x and then multiplying it by the number, which is 1/3. So the derivative here would be 1/3 times, now the derivative of 4 to the x, which is natural log of 4 times 4 to the x. Alright, this problem has the power rule and the exponential rule mixed up in it, and that's what's going to happen a lot of times on some of what we'll see. It's just going to have all the rules together, so let's look at that. We want to find the derivative of 3 to the x, so that would be natural log of 3 times 3 to the x. And then I want to do the derivative of x to the third, which I'll use the power rule because 3 is the power, which would be 3x squared. So the answers are going to kind of look different. They're going to have more complicated things, but that's okay. Alright, number 5. So we found out that the derivative of e to the x is e to the x, so that's just e to the x. And then the derivative of square root of x, I would probably rewrite it as x to the 1/2 and then think about how to find that using the power rule. I'm going to bring the 1/2 down, subtract 1 on the power, 1/2 minus 1, and then that's the answer. Alright, this one is just 2 times a function, so just bring that 2 down, find the derivative of the function, it's just e to the x, so that's your answer. Number 7, similar as the others, I like to rewrite it as 1/5 times e to the x. Just think it's easier to notice that way, how to find the derivative. So the derivative is going to be, leave the 1/5, find the derivative of e to the x, which is just e to the x. This next one's kind of weird. First of all, we're going to use the exponential rule. The reason is because x is the power. Natural log of 8 is a number, and it's just inside the parentheses. So my rule is that it's natural log of whatever's inside the parentheses. So it's natural log of 8, and then times whatever's in parentheses to the power, times natural log of 8 to the x. And I can't combine any of that. It's just weird looking. Number 9. This is x to the ln of 8. ln of 8 is a number. The number is in the power. That means that on this problem we're using the power rule. Being able to go back and forth between the two rules are important. So the natural log of 8 will come down in front. Leave your x, natural log of 8, and then minus 1. Alright, just so you know, that is not natural log of 7. You don't have to put this parentheses, but if it helps you to see it, that's really just natural log of 8 and then minus 1. Alright, number 10. I'm going to find the derivative of 5 to the x. So that's natural log of 5 times 5 to the x. Then I'm going to find the derivative of 5 over square root of x. That's the same as 5x to the negative 1/2. So that would be negative 5/2 because I'm multiplying the 5 and the negative 1/2. X to the power, I do negative 1/2 minus 1. And then lastly it says 5e to the x, so I know it's a minus 5. The derivative of e to the x is e to the x, so we have e to the x in our answer. I have some problems for you to try today. Just using the new rule, and it does have, there's a couple with the power rule as well. On number 2, I want you to know that's 4 times 5 to the x. It's not 4.5, it's 4 times 5 to the x.